NOC-AD, through the DoD National Defense Education Program, sponsored the Air Talent Program, which invited 8 undergraduate teams to solve real aviation challenges facing the Navy today. Let's take a look at some of the projects, what the students learned, and the impact on the Navy. The Strength 22 team focused on creating strong and lightweight floor panels for the V-22 Osprey platform to allow the aircraft to carry more people and cargo.
The whole goal of our project and the way we approached it it's to break things and iteratively break things, build something, break it again, and at the end hopefully have something that doesn't break. So it's a continuous process.
Failure is just a criticism of our weaknesses and helps us to grow as stronger engineers.
I found this project to probably be the most enriching experience I've had as an engineer. It's really allowed me to build on everything that I've learned in the classroom.
Found certain ways how to not make a panel. We basically had to build our testing apparatuses before we were even able to start our work on the panels. However, now that that groundwork has been laid and that foundation's been built, I think future programs will seriously benefit from the rigs that we have made, so they'll be able to jump right into more creative design.
The Hopkins Speed 22 team tackled how to stabilize sling loads under aircraft, such as helicopters or vertical lift planes. They discovered early on that creating a container to carry multiple objects would enable the aircraft to carry a variety of loads safer and faster.
I think one thing that I learned that was kind of eye-opening was when we went to the actual lab at Naval and saw the big mural that says, "How do you support the warfighter today?" You really get the understanding that, their projects are made to help whatever that job is in the military.
Seeing the dedication to mission statement that the Navy has and the Naval has whenever we visited is, I've worked at companies in the past and sometimes the commitment to mission is not always as great, but with the Navy, I could really tell that everyone was super dedicated and super invested in helping the warfighter whenever and however they can.
This next project developed time-of-flight cameras specifically for underwater use. Why? Check it out.
The primary technology for this project, at least, is the time-of-flight camera. There was a lot of other things that we had to work beside it as well to get the results that we did, but the primary thing is the time-of-flight camera, which allows us to take depth imagery of whatever we pointed at. And so depth imagery is distinct from regular imagery in that every pixel that you get from this depth image has a depth value associated with it. So as you take a picture, you know just how far away like the tree behind us is, or just how far away whatever else in the shot is. And this is really helpful, but when you have this depth camera, you can make a lot more important decisions for perhaps like an autonomous vehicle or something like that.
The big thing that we did to our camera is we modified it to, instead of work from infrared light, it now works using green light. And the reason for that is green light travels better through water, which is where we specifically wanted to use our camera.
It was great to have a student team who had so many skills and capabilities explore this technology basically on my behalf. And also it was impressive that this team they built the hardware, they built software, they did experiments, they made additional software packages to find objects in the scene that was really some great capability built up in just the span of 1 year.
Here at NOC-AD, people are our greatest resource. The Medusa model, developed by the George Mason University team, calculates the necessary human capital to support existing and developing aircraft needs.
The outcome of our project has been really valuable. With a completed model, we're able to run multiple case studies, and these case studies have showed us with any variety of missions for a 7-day period, we're able to see, do you need extra pilots, extra maintenance, extra air crew, or can you reduce the amount that we're currently thinking are Navy standards?
So what I've observed is as the Navy's thinking about what its future vertical lift aircraft are going to be, there hasn't been much thought on manpower. So about 30% of the Navy's budget goes towards manpower. So taking a bottoms-up approach and looking at what our staffing requirements are, where we can make trades, where we may need to ask for more manpower is going to be hugely important.
Air Talent provides students with an opportunity to showcase their skills, gain hands-on experience, and learn about Navy science and technology. Students bring new ideas, innovation, and perspective to help the Navy launch cutting-edge technology. Want to learn more? Visit our website or contact us at these emails.